Hello today. Now we are going to learn how to add n vectors. That means it can be more than 2 vectors. It can be 3, 4, 5, etc. Before studying that, we have to remember triangle of vector addition. By triangle, we mean if we represent two given vectors a b vector and q vector by the adjacent sides of a triangle taken in the same order, then the resultant is represented by the closing side of the triangle taken in the reverse order. Here, this is p vector and it is towards right, then it is q vector, it is in this direction. Now if we join the tail of p vector to the tip of q vector, it will give the resultant of p vector and q vector. That means it is p vector plus q vector. Okay. Now if you have a number of vectors, then we can represent the vectors by the sides of a polygon, sides of an open polygon taken in the same order. That means this is an open polygon, it is not closed at this side. The side of the polygon, that means OA represents the vector p vector, then the other vector q vector is placed with its tail at the tip of p vector and it is represented by AB vector, like this. Now the next vector is S vector. It is represented along BC, the side BC of the open polygon. Then the last vector, that means here we have to add 4 vectors. Which are the vectors? P vector, Q vector, S vector and T vector. These vectors can be shifted parallel to themselves and arranged like this by the sides of an open polygon taken in the same order. These are the same order, direction wise. These are the same order. That means here they are in the anti-clockwise direction, represented by the sides of the polygon taken in the anti-clockwise direction. Now, if these sides represent the given vectors, then the closing side of the polygon, that means OD, taken in the reverse order. These vectors are in the anti-clockwise direction, while this vector is in the clockwise direction, the opposite direction. And so this side taken the reverse order, that means having direction from O to D, represents the resultant R vector in magnitude and direction. This is known as a polygon law of vector addition. That means if we represent a number of given vectors by the corresponding sides of a polygon taken in the same order, then the closing side of the polygon taken in the reverse order represents their resultant in magnitude and direction. That means from this figure we can write R vector as P vector plus Q vector plus S vector plus T vector. S vector plus T vector. So this is the resultant vector given by polygon law of vector addition. Okay. Now let us see the method by which a vector q vector is subtracted from another vector p vector. P vector minus q vector means it is sum of p vector and another vector minus q vector. So this can be written as p vector plus minus q vector. These two may look like the same, but their geometrical meaning is quite different. Here, p vector minus q vector is this. In this case, the two vectors are acting in the same direction. This vector has a magnitude of 5 units and this vector has a magnitude of 3 units. They are the same direction. Then p vector minus q vector means p vector plus minus q vector. That means the vector q vector is reversed. That means this is the vector minus q vector and then added to p vector. This is towards right and this is towards left. So when they are added, we get the resultant as having a magnitude of 2 units in the direction of the greater vector p vector. That is, this is p vector minus q vector. when the two vectors p vector and q vector are acting in the same direction along a straight line. But in this case, when the direction of q vector is opposite to that of p vector minus q vector can be written in the same way as p vector plus minus q vector. But here minus q vector means the reverse vector of q vector. This is towards left and this is minus q vector is towards the right. So when they are added, we get p vector minus q vector as a vector having a magnitude equal to 8 units. Okay. Now, in the case of two dimensions, we can subtract q vector from p vector. Here, p vector is in this direction and q vector is towards the right. These two vectors are the given vectors. They are inclined at an angle. Now, in order to subtract q vector from p vector, as in the earlier case, q vector is reversed. That means another vector of magnitude, same magnitude and in the opposite direction. That means minus q vector is formed by reversing q vector. A line of the same length is drawn in the opposite direction. Now this line segment represents a minus q vector if its direction is in this direction. Now this minus q vector and p vector, when added, we will get q vector minus q vector. That means when a parallelogram is completed with the sides p vector and minus q vector, then the diagonal of the parallelogram represents the resultant vector. That means p vector minus q vector. This is p vector minus q vector. This diagonal represents a p vector minus q vector. Usually we employ this in the case of relative motion, relative velocity, relative displacements, etc. Okay. Now let us try to understand resolution of a vector in a plane. Here three vectors are shown. A vector is the given vector which is to be resolved into two vectors in the direction of the two given vectors A vector and B vector. Capital A vector is to be resolved into two components in the directions of the two given vectors, small a vector and small b vector. What is meant by resolution of a vector? By resolution of a vector we mean the splitting up of a vector into two or more components. ഒരു വെക്ടറിനെ നമുക്ക് വേണമെങ്കിൽ അതിൻ്റെ അതേ എഫക്റ്റ് ഉണ്ടാകുന്ന രീതിയിൽ രണ്ടോ അതിലധികമോ വെക്ടേഴ്സ് ആയിട്ട് റിസോൾവ് ചെയ്ത് മാറ്റാൻ പറ്റും. എന്ന് പറഞ്ഞാൽ ആ വെക്ടറിന് പകരം ആ രണ്ടോ അതിലധികമോ വെക്ടേഴ്സ് ഒരുമിച്ച് പ്രവർത്തിച്ച് അതേ ഫലം തന്നെ ഉണ്ടാകും എന്നാണ് അർത്ഥം. Here we are going to resolve or split the vector capital A vector into two components which are in the directions of the two other given vectors, small a vector and small b vector. For that, let us represent the tail of A vector as O and the tip of A vector as P. Now, in order to resolve this vector into two components, we can draw lines parallel to the two given vectors, small a vector and small b vector, through the tail and the tip of A vector. That means we have to draw a line parallel to small a vector, through the tail O. This is the line drawn parallel to small a vector. Now we can draw another line parallel to B vector through the tip P of A vector. This line will be parallel to B vector. Let these two lines meet. Thus, we have drawn two lines through O and B parallel to A and B, A vector and B vector respectively. Let these two lines meet at the point Q. Now, this may be represented as OQ vector and QP vector. Now clearly from the diagram we can write capital A vector equals OP vector, and this OP vector is equal to OQ vector plus QP vector. ഇതിന്റെ വെക്ടർ സമായിരിക്കും OQ വെക്ടറിന്റെയും QP വെക്ടറിന്റെയും വെക്ടർ സമായിരിക്കും OP വെക്ടർ. നമുക്കറിയാം ബൈ ട്രയാങ്കിൾ. അതുപോലെ നമുക്ക് ഡിസ്പ്ലേസ്മെന്റ് ടേംസിൽ ആലോചിച്ചാലും മനസ്സിലാവും. ഒരു ഓബ്ജക്റ്റ് ഇവിടെ നിന്ന് ഇങ്ങോട്ട് ഡിസ്പ്ലേസ് ചെയ്തു, അവിടെ നിന്ന് ഇങ്ങോട്ട് ഡിസ്പ്ലേസ് ചെയ്തു. സോ ദ ഫൈനൽ ഡിസ്പ്ലേസ്മെന്റ് വിൽ ബി ദ ലൈൻ ജോയിൻ ദ ഇനിഷ്യൽ പോയിന്റ് ടു ദ ഫൈനൽ പോയിന്റ്. അപ്പോൾ OP ആയിരിക്കും റിസൾട്ടന്റ് ആയിട്ടുള്ള ഡിസ്പ്ലേസ്മെന്റ്. ദ സിംപ്ലസ്റ്റ് വെക്ടർ എന്ന് പറയുന്നത് ഡിസ്പ്ലേസ്മെന്റ് വെക്ടർ ആയതുകൊണ്ട് നമുക്ക് വെക്ടേഴ്സിന്റെ അഡീഷൻ, സബ്ട്രാക്ഷൻ മുതലായ കാര്യങ്ങളൊക്കെ ഡിസ്പ്ലേസ്മെന്റ് ടേംസിൽ വിഷ്വലൈസ് ചെയ്യാൻ പറ്റും. അതുകൊണ്ട് ഇവിടെ OP വെക്ടർ എന്ന് പറയുന്നത് OQ വെക്ടർ പ്ലസ് QP വെക്ടർ നമുക്ക് എഴുതാൻ പറ്റും. ഇനി നമ്മൾ മനസ്സിലാക്കുന്ന കാര്യം, we are going to express capital A vector in terms of the two given vectors small a vector and small b vector. This can be done by dividing the magnitude of OQ vector by the magnitude of A vector. That means if you find OQ divided by small a, OQ divided by small a, it will be a scalar, it will be a number, let it be lambda. Then we can represent OQ vector by lambda into small a vector. OQ will be equal to lambda into A. So OQ vector can be written as lambda into small a vector. Since A vector and OQ vector are parallel, we can represent OQ vector as lambda into small a vector, where lambda is a scalar. Similarly, this QP vector is parallel to B vector, so we can obtain QP vector by multiplying small b vector with another scalar, say mu. Then we can write QP vector as plus mu into B vector, where OQ divided by small a is lambda and QP divided by small b is mu. Thus, we express the given vector capital A vector in terms of two other given vectors, small a vector and small b vector. That means we have resolved A vector into two components, one in the direction of small a vector and the other in the direction of small b vector, and thus we express this. This is the component of A vector in the direction of small a vector, and this is the component of A vector in the direction of small b vector. This is the resolution of A vector. So by resolution we mean the splitting up of a given vector into two or more component vectors. Now, it will be convenient if we express a vector in a plane or space in terms of unit vectors in the directions of the rectangular coordinates OX, OY and OZ respectively. We take the unit vectors along OX, OY and OZ as I cap, J cap and K cap respectively. These are the unit vectors along the coordinate axis. I cap along OX, J cap along OY and K cap along OZ. The unit vectors, these are the unit vectors. I cap, J cap and K cap are the unit vectors along OX, OY and OZ respectively. The unit vectors in the opposite directions will be minus I cap along the negative x direction and minus J cap along the negative y direction, minus K cap along the negative z direction. We have seen the method by which a given vector, capital A vector, is expressed in terms of two other given vectors, small a vector and small b vector, in its own plane, like A vector into lambda plus B vector into mu, or lambda into A vector plus mu into B vector. Here these two are the components of this vector expressed in terms of the two vectors, small a vector and small b vector, in its own plane. Here lambda and mu are scalars. Now it would be convenient if we express a given vector in terms of its rectangular components. The rectangular components are expressed in terms of unit vectors along the rectangular coordinate system. The unit vectors along the rectangular coordinate system, that means along OX, OY and OZ, are represented by I cap, J cap and K cap respectively. What do you mean by unit vectors? Unit vectors are vectors with the unit magnitude. They have no dimension and no unit. Unit vectors do not have dimensions or units. Such unit vectors can be used to represent the given vector A vector. Here A vector is given and it is represented from the origin O in the XOY plane as in this figure. Now, in order to express this vector in terms of the unit vectors along X and Y axis, we draw perpendiculars from the tip of this vector onto the axis OX and OY as shown in the figure C. Now this length is the magnitude of the X component of this vector and it is given by Ax. Ax is the modulus of the X component of A vector, and the vector component is given by Ax into I cap. If this is A1 vector and this is A2 vector, then we can express capital A vector equals A1 vector plus A2 vector, where A1 vector has the magnitude Ax, so this is equal to Ax into I cap plus and plus A2 vector means Ay into J cap. This is the method by which a given vector A vector is resolved into its rectangular components along OX and OY. Ax into I cap is the vector component along the x-axis, while Ay into J cap is its vector component along the y-axis. The modulus of the x component is Ax, while the modulus of the y component is Ay. Now, if we mark the angle made by the vector with the positive direction of x-axis as theta, we can express the value of Ax and Ay in terms of the modulus of A vector. That means from the figure we see that cos theta equals Ax divided by modulus of A vector means A. So this gives Ax equals A into cos theta. Similarly, sin theta equals Ay divided by A. It gives that Ay equals A into sin theta. And also by dividing this with this we get tan theta equals A sin theta by A cos theta, or it is equal to Ay divided by Ax, or this implies that theta equals tan inverse of Ay by Ax. Thus we obtained the magnitude of the x component and y component as Ax equals A cos theta, Ay equals A sin theta, and also the angle made by the vector with the positive direction of x-axis as theta equals tan inverse of ay divided by ax. And also by squaring these two terms and adding, we get ax square plus ay square equals a square into cos square theta plus sin square theta. So we get a equals from that we get a square into cos square theta plus sin square theta equals ax square plus ay square. Therefore, a equals, this is 1, therefore a square into 1 equals this, or a is equal to square root of ax square plus ay square. Thus we expressed the given modulus of the given vector in terms of the moduli of the x component and y component. Okay. Now let us find the sum or difference of two vectors expressed in terms of the rectangular components. As this is the first vector, a vector. This can be expressed in terms of the rectangular components using this figure as ax into I cap plus ay into j cap. Now, if another vector b vector is expressed in the same way, then we get bx into I cap. B vector equals bx into I cap plus by into j cap. Now, the vector sum of these two vectors is given by r vector equals a vector plus b vector. This is equal to ax into I cap plus ay into j cap plus bx into I cap plus by into j cap. This is equal to, we can add the x components. That means this is equal to ax plus bx into I cap plus ay plus by into j cap. Thus, the resultant vector of a vector and b vector is expressed in terms of its rectangular components. The resultant vector, capital R vector, is expressed in terms of its rectangular components. We know that this resultant vector R vector can directly be expressed in terms of its components Rx and Ry, as R vector equals Rx into I cap plus Ry into Rx into I cap plus Ry into j cap. Now comparing these two equations, comparing 1 and 2, from 1 and 2 we get Rx equals ax plus bx and Ry equals ay plus by. We get Rx equals ax plus bx, then Ry equals ay plus by. From this, it is clear that the x component and y component of the resultant vector is obtained by adding the x components of the given two vectors and the y components of the given two vectors. So, in order to add two vectors, it is enough if we add their rectangular components, their respective rectangular components, x components and y components. When the x components are added, we get the x component of the resultant as Rx equals ax plus bx, and the y component of the resultant is obtained by adding the y components of the vectors ay and by. Okay. Now let us see the method by which a vector is resolved in three-dimensional space. Here a vector, capital A vector, is shown in three-dimensional space. Its components along the x-axis I cap into ax, along the y-axis j cap into ay, and along the z-axis is k cap into az. So the vector can be expressed as a vector equals ax into I cap plus ay into j cap plus az into k cap, where the modulus of the vector is given by a is equal to square root of ax square plus ay square plus az square. This is the length of this line segment. It is equal to ax square plus ay square plus az square. Ax, ay and az. Now the angles made by the vector with the directions of x-axis, y-axis and z-axis are respectively alpha, beta and gamma. Alpha is this angle, beta is this angle and gamma is this angle. From figure we see that the length ax divided by the length a equals cos alpha. That means we see that ax divided by a equals cos alpha. Therefore, this implies that ax equals a into cos alpha. Ax equals a into cos alpha. Similarly, ay divided by a equals cos beta. Or we get ay equals a into cos beta. Az divided by a is equal to cos gamma. Therefore, this implies that az equals a into cos gamma. So, these are the components of a along the x, y and z axis in terms of the magnitude of a and the angles made by the vector with the positive directions of x, y and z axis. ഈ രൂപത്തിൽ തന്നെ നമുക്ക് മറ്റ് വെക്ടേഴ്സിനെ എക്സ്പ്രസ് ചെയ്യുകയാണെങ്കിൽ ഇതിൻ്റെ അഡീഷൻസ് ഒക്കെ എങ്ങനെ നടത്താൻ പറ്റും, അഡീഷനോ സബ്ട്രാക്ഷനോ ഒക്കെ ഏത് രീതിയിൽ എളുപ്പത്തിൽ ചെയ്യാൻ പറ്റുമെന്ന് മനസ്സിലാക്കാൻ ശ്രമിക്കുക. ശ്രദ്ധിക്കുക, ബി വെക്ടർ എന്ന് പറയുന്ന ഒരു വെക്ടർ നമുക്ക് ഇതുപോലെ തന്നെ ബി എക്സ് ഇൻറ്റു ഐ ക്യാപ്പ് പ്ലസ് ബി വൈ ഇൻറ്റു ജെ ക്യാപ്പ് പ്ലസ് ബി ഇസഡ് ഇൻറ്റു കെ ക്യാപ്പ് ആ രൂപത്തിൽ എഴുതാം. അതുപോലെ തന്നെ സി വെക്ടർ ഈക്വൽസ് സി എക്സ് ഇൻറ്റു ഐ ക്യാപ്പ് പ്ലസ് സി വൈ ഇൻറ്റു ജെ ക്യാപ്പ് പ്ലസ് സി ഇസഡ് ഇൻറ്റു കെ ക്യാപ്പ്. ഈ രീതിയിൽ രണ്ട് വെക്ടേഴ്സ് കൂടി നമ്മൾ ഇതേ രീതിയിൽ എക്സ്പ്രസ് ചെയ്തിരിക്കുക. Now let us find the resultant of all the three vectors, a vector, b vector and c vector. Then it is given by r vector equals a vector plus b vector plus c vector. A vector plus b vector plus c vector. This is equal to, a vector means ax into I cap plus ay into j cap plus az into k cap, and b vector means plus bx into I cap plus by into j cap plus bz into k cap, and c vector means cx into I cap plus cy into j cap plus cz into k cap. Now we can collect I cap from all the three vectors. Then we get ax plus bx plus cx into I cap. Similarly, ay plus by plus cy into j cap plus az plus Bz plus Cz into k cap. This can be compared with the resolved expression of R vector. We can resolve R vector like this. R vector equals Rx into I cap plus Ry into j cap plus Rz into k cap. Comparing these two relations, we see that Rx equals Ax plus Bx plus Cx. Ry equals Ay plus By plus Cy, and Rz equals Az plus Bz plus Cz. Thus we see that in order to add three vectors, it is enough if we add the x components together and multiply with I cap, then the y components together and multiply with the j cap, and the z components together and multiply with the k cap. These are the magnitudes of the x component, y component and z component. While the vector components are ax plus bx plus cx into I cap. Similarly, the vector y component is ay plus by plus cy into j cap, and the z vector component is az plus bz plus cz into k cap. So, in order to add three vectors, we can express them in terms of the rectangular unit vectors I cap, j cap and k cap, and then we can find the vector sum by adding the respective components along x axis, y axis and z axis. Vector subtraction can also be done using the same method. As an example, if you want to find R vector equals A vector plus B vector then minus C vector, then the x component, y component and z component of the resultant R vector will be Ax plus Bx. Rx equals Ax plus Bx minus Cx, and Ry is equal to Ay plus By minus Cy, and Rz will be equal to Az plus Bz minus Cz. Okay.